Okay, so this is Journal 53. We're not going to do a bell work here. We're going to go straight into today's lesson. So we've learned a lot of different ways for solving logs and exponentials, but now it's like we have all these, we've seen all these skills, but how do we know which one to use when we need to solve a log, right? So today it's all about learning or refining all those skills you learn, and so you can figure out which one to use strategically. So what I mean is, if you're given a log problem, which is the best strategy to use to solve the problem easier or quicker? So I'm going to give you 4 tips on how I can look at an equation and be able to figure out what strategy to use, or how to start a problem. So the first tip is if the log is already by itself. So if you notice, these problems here, these logs don't have anything next to the log or outside the log, right? There's no number next to it or a plus minus a number after it. So everything's encapsulated inside the log. So if the log is by itself, change it to an exponential or change it to an exponent. You can use the heart method to do this and then solve for x. So we're going to do a few examples here to demonstrate that. But you guys have been doing this a lot, especially in page 2 of packet 11. You do this where you're trying to get x by itself by using the heart method. So with part A, I'm going to start with the base, go to the fraction, then the x. So this is 27 to the 1/3 equals x. So let's see, 27 to the 1/3 power. Now you can do this in the calculator if you know where the power button is. It's that upside down V-shaped button under the clear button. So if you hit that on a calculator, or if you want to do this by hand, this exponent here, 1/3, is just saying take the cube root of 27. So if you know what the cube root of 27 is. So I find that when I put this in the calculator, 27 to the 1/3, I get 3. And so this is my answer. X is equal to 3. Okay, next I'm going to take a look at this problem here. Notice that this doesn't have a base, so I'm going to write the base there because the base is 10 by default. And then I'm going to do the heart method because the log is by itself, so I can change it to an exponent. So this is 10 to the 4.1 power equals x. Now x is by itself, so I have to figure out what 10 to the 4.1 power is. Let's see. Okay, so I got a really big number here. I got, looks like 12,589. I'm going to round to 3 decimal places, 254 if I round. And yeah, that's it. So x is by itself, so that's my answer there. Box that in. Okay, let's take a look at part C. So part C here, the log is already by itself. Everything in this parentheses is so everything inside this log is encapsulated, so that's why I know that this 2x minus 1 is inside the log. So if I use the heart method, I'm going from 3 to 4 to 2x minus 1, so 3 to the 4th power equals 2x minus 1. 3 to the 4th power. 3 to the 4th power is 3 times 3, 4 times. That's 81 equals 2x minus 1. So now I have to try to get this x by itself. Maybe add 1 to both sides first. 2x is left over. And then 81 plus 1 is 82. Divide that by 2 to get rid of the 2. And that cancels. So x is equal to 41. Okay, now some of you who are paying very close attention might have been like, wait a minute, Miss Chang, why didn't you check your answer? Because this is a log problem. You should check your answer to see if the log doesn't give you a negative or a 0. Okay, you caught me. I definitely need to check my answer. But I also was fully aware that the equation here, like the first one here, just had an x in it. Okay, so that means whatever my x value I got, if it was a positive, it would work out. Like if I plug this 3 back in for this x, it's just a positive 3 inside the log, so that's fine. So this here is good. And this one here just had an x. And so if I plug in a really big number, but it's positive, it's going to still be good. So We still have a positive number inside the log. And last but not least, this log here has a 2 times x. So 41, plug this 41 in for this x, gives you like 82 minus 1, still a positive number. So there's no negative numbers or zeros here, which is good. I do want to mention most of the time, if you forget to check your answer, you'll be fine. However, the times that you really want to check your answer for logs is when you're solving it out and you notice that there's a quadratic inside the log, okay? Because quadratics come out to have 2 answers, and generally one of the answers will fail. So always check your answer when you have a quadratic equation to deal with. And we'll see an example like this here in the next few slides. So we're going to move on to tip number 2. Okay, so tip number 2 is very similar to tip number 1, only it's basically you're in that situation where the log is not by itself. So check out these logs here. There's some extra pieces sticking to the side of the log. So that means that you need to move the numbers over that's not encapsulated in the logs until the log is finally by itself. Because once the log is by itself, well, then we're back to tip number 1. You have to change the log into an exponential. So let's take a look at the first one here. Part A, we have log base 2, 8x. And that entire thing is encapsulated in the log, the 2 and the 8x. But the 4 is not included. So that means we need to get rid of the 4. So we divide both sides by 4 to get rid of it. And so now we have log base 2, 8x. 16 divided by 4 gives me 4. And voila, the log is by itself now. So now I can change it to an exponential. So I'm going to do the heart method. So this is 2 to the 4 equals 8x. And so 2 to the 4th power is 2 times 2 times 2 times 2 is equal to 16. 8x is still left on this side. Then I have to divide by 8. That cancels. And x is now by itself. 16 divided by 8. 2. And there we have it. We have x by itself, but hold up. Feel free to check your answer. Let's make sure that this is a valid answer here for x. So plug this 2 back in for this x. 8 times 2, 16. That's a positive number. So we're good. I'll put a little check mark there. Okay, let's take a look at this problem here. So the log has the negative 5x encapsulated, but the 2 here, not a part of the log. It's outside the log. So I have to subtract that off. Easy peasy. So now I have log, oh, what's the base here? 10, because it's not there. And so 4 minus 2 gives you 2. And so log is by itself. Now I can change it to an exponential. So I'm going to go ahead and make my heart. So this is 10 squared equals negative 5x. And now if I want to simplify this, 10 squared gives me 100. Because 10 times 10. Negative 5x is on this side. Now I'm going to divide this by negative 5 to cancel that out. So that's canceled. And then x drops down. 100 divided by negative 5. Let's think about this. Negative 20. So I have arrived at my x value, but this x value is a negative. Maybe suspicious here, better check. So if I plug this negative 20 in, it looks like I'm okay, because negative 20 times 5, but it's a negative 5, makes it a positive number, a positive 100. So this is a valid answer. Okay, so step 2 is basically if the log is not by itself, then remove the extra stuff over until the log is by itself. All right, let's head on over to tip number 3. Okay, so tip number 3 is if you have an exponential, so this time that's not a log problem, you got a base with an exponent that has an x in it. So this is what we call an exponential. If you have that, you got to convert it to a log. It's just like when you have a log, you convert it to an exponential. So this is like the opposite, okay? So if I want to try to get this x down, I have to change it to a log. Now, you can use the heart method here. The only thing you got to remember is Just like how you convert logs, the exponential needs to be on the left-hand side, and it needs to be by itself, which is true here in this case. But the thing that people sometimes will forget is make sure you write a log before you start the heart method. I like to write the log first, so that way I don't forget. And so when you use your heart method, you also start from the base, then you go to the 2, 5, 6, and then you land at x plus 3. So this is log base 2, 256 equals x plus 3, and now I have it set up. Okay, so from here, let's see what we can do. There's our x, so we need to get this x by itself. Maybe let's clean up this side here first. Like log base 2, 256, we can actually calculate this if we use our graphing calculators. So if you get a calculator out, remember, if you want to use logs in the calculator, you're going to hit math, and then you're going to scroll down to base, log base, and put in the base and the 256. And if you do that, you get 8. Now, if you don't do that, basically, if you want to do this by hand, you basically have to ask yourself, okay, 2 to some power gives you 256. Well, apparently 2 to the 8th power gives you 256. Remember, logs give you exponents. Now, I'm going to drop down the x plus 3 next. And so to get this x by itself, I got to subtract 3 to both sides. That cancels. X drops down. 8 minus 3 gives you 5. Now, this is an exponential function, so I don't have to check my answer, which is nice. Less work for me to do. Okay, let's move on to tip number 4. Okay, so tip number 4 is like everyone's favorite tip. If you notice that both sides of the equal signs have the same base, whether that be an exponential has the same base or a log has the same base, well, that means that both sides cancel, and that gets rid of a lot of stuff, right? And so for exponentials, like this first problem here, if the 14 is on both sides, the base is both 14, they cancel, dropping down the exponents. Like this first one here, the 3x plus 1 drops down. The equal signs between them, so that has to drop down. And the 6x minus 8 also drops down, and now you're just solving for x. So if I were to solve for x, maybe I'll subtract 3x from both sides first. That cancels, so I just have a 1 that's left on this side. And 6x minus 3x is 3x minus 8. Maybe add 8 to both sides. That cancels. So I have a 3x left on this side. 1 plus 8 is 9. If I get this x by itself, I have to divide by 3. That cancels. So x is equal to 9 divided by 3 is 3. And so x is by itself. And this is an exponential, so I don't have to check my answer. Woo! Okay, B is next. And with this one here, the base is both the same, so they cancel. And so now the stuff that's inside the logs comes out, and that means I have an x squared that comes out minus 9. Drop down that equal sign because that's between them, and the 8x comes down. So right away when I notice I set them equal to each other, I have a quadratic. I have x squared, so I have a quadratic equation. So that means I need to get it in standard form and then use either factoring or the quadratic formula to solve for x. So to do that, let's first figure out which one I should move over to try to get one side to be 0. Well, it's easier to move over this 8x to that side because I would just be moving one item. So if I try to get rid of the 8x on that side, I have to subtract by 8x. That cancels. So this side is equal to 0. And then on this side, you know what? I think I'm going to write the exponents in order. So I'm going to have x squared minus 8x minus 9. So that way I have it kind of already set up where the exponents are in order. Because typically when we see quadratics, it's usually in this order. Okay, so if I were to factor, let's figure out what multiplies to give me 9 but adds to give me negative 8. So if I do set this up, I need x's here to make 9, but also to make 8. Maybe 9 times 1 will work. So if I drop down a 9 and a 1, Let's think about it. I have the middle term is a negative 8. So that means the bigger number needs to be a negative, smaller number is positive. All right, let's check our answer. Negative 9 plus positive 1 gives me negative 8, so it looks like it works out. And also negative 9 times positive 1 gives me negative 9. So hard part's over. Now I just have to set the factors equal to 0. Almost there. So if I add 9 to both sides, that cancels. X is equal to 9 for the first one. This one, if I subtract 1 from both sides, X is now by itself, and X is equal to negative 1. Okay, but this one was a quadratic, so what do we need to do next? Well, we need to check our answers, because quadratics are always the wonky ones. Usually one of them fails. So let's try out this X first. So this X is a 9. If I plug 9 in, 9 squared, 81 minus 9, 72, it's a positive number, so we're fine. If I plug 9 into that one, because it also has an X, 8 times 9, 72, positive number. So this one is a green light for me, so it's valid. This one here, negative 1. If I plug it into this log, 8 times negative 1, it's going to be a negative 8 inside. Not good. Not good. So this is going to be not valid. And it looks like X equals 9 is our only valid answer here. All right, so that's it for the 4 tips, but I still want to show you guys this formula here in the next slide. It's called the change of base formula, and this is really helpful, especially for those of you who don't have a graphing calculator. Okay, so the change of base formula is basically a formula that allows us to write a log or calculate the log using log base 10. Okay, so this, if you know what the log is, the base and the value, you can figure out what that is straight up in the calculator. Like I can plug this into the calculator if I hit math and go to log base, plug in the base, plug in 1 over 16, right? You can get the answer very quickly. But if you don't have a graphing calculator, then you're kind of stuck. You can't figure it out. So most calculators have a log button, but it's a log base 10. So let's try to understand this formula, because I know most of you can't afford a TI-84 graphing calculator. Those things are super expensive. They're over $100. But some of you might be interested in purchasing a calculator that can do more functions than your typical iPhone, you know. So if you're interested in using logs or purchasing a calculator, one of the really nice calculators out there is it's called like the TI 30X. And those calculators have log buttons. They also have fractions. They can do powers. A lot of things that basic arithmetic you use in Algebra 2. Just not the graphing part. So like this problem here, let's go back to this formula. So you'll notice that the value, the a, is in the numerator with its own log, and the base is in the denominator. So how I remember this formula is that base is in the bottom, b, bottom, both b's. So both of these bases are 10. I'm just going to write that there so it kind of reminds us. So here, if I were to rewrite this using the change of base, I can write this as log base 10. Actually, I don't even need to write that 10 there. Let me write this as log, and then in the numerator it's going to be the 116 over log 4. And so if I take log 1 over 16 and divide it by log 4, I'm going to get my answer, which is going to be, if I do this in the calculator, negative 2. So if you don't have a graphing calculator, just split the value and the base using a fraction and give them both a log base 10, okay? And actually, I think the iPhone and most smartphones have a log button in it. If they do, check it out, because you might be able to do this problem in your phones. So Anyhow, I thought I'd share that tip with you guys. This is a nifty formula to know, especially, well, you're going to need to know for the test, but also just in general, if you're solving log problems and you don't have a graphing calculator at home, you can still solve it using log base 10. All right, that's it for this journal for today. And now in the next slide, so I would stay on, I'm not done with this video because in the next slide here, I'm actually going to do one of the homework problems. So if you get out your packet 11, I'm going to do problem 10. So I would try to get that freebie in. All right, so this is page 5, number 10 on that packet. So this problem's a little tough, and so that's why I'm doing this problem with you guys. But let's use the 4 tips that we learned here to figure out which strategy would be good to use here. So right away, what I noticed with this problem here, there's a log, and the log is by itself. So this really, for me, is like tip number 1, which is to change the log to an exponential, or an exponent. So in this case, we're going to go from the base to the fraction to the 32. Basically, I just used the hard method to change it to an exponential. So this is x 5 over 2 equals 32. So when I see this, I'm like, ooh, the base here is the x. Usually x is on that side. Oh dear, how do I get this fraction exponent off of it so x is by itself? Well, one way we can tackle this problem is if we think about rational exponents. So we learned a while ago, if we have a rational exponent, rational just means fraction, so fraction exponent, we can change it to a root. So a root is, for this m over n, well, the denominator tells us our root with this exponent. So n is our root, so that goes outside. And m is our exponent, so that goes inside. We learned this a few chapters before this. So that's how you can convert from a power to a root. So with this one here, if I were to convert, x would be inside. The 2 here in the denominator is my root, so this is actually a square root. And the 5 here goes on the x in the inside as a power. And this side still equals 32. But now when I see it this way, then I'm like, oh, well, x is inside, so I need to get rid of a square root. How do I get rid of a square root? Well, that's by squaring both sides. To get rid of a root, we raise it to the power of the root. So the power on this root is 2. And so I have to raise this to the power of 2. That cancels out the root and the power. And so now I'm just left with x to the 5th power, 32 to the 2nd power. Now I'm not gifted, so I'm going to need a calculator for this. So I'm going to go grab my calculator and multiply 32 with 32. And that gives me 104. I'm sorry, 124. Okay, so from here, if I have a 5 as my power and I want to get rid of it, I have to take the root. Remember, roots and powers undo each other. They're inverses of each other. So I have to undo the 5th power by taking the 5th root. So that cancels out. And now I'm left with x on this side, which is good. And then the 5th root of 1024 is 4. And voila, x is by itself. Yep, and I am finished here. Okay, so that's basically it for this video. Feel free to try out now the other problems. Really, when you look at a problem, first figure out what strategy you want to use. So think about what tip you want to use here to get you started. And if that doesn't work, then you can always try something else too. Anyhow, I hope that helps you out. I'll see you guys in class.